and you will find the group. So for group 7, the mean lambda is what? Actually, mean of Poisson distribution is given as 12. For group 8, it is 25, 27, 17, 28, and 23. So now here you can use your R software to generate the Poisson distribution. Do you know how to generate Poisson distribution using the software R? Do you know? Don't tell no. I know you have been taught in the class by Professor Roy Chaudhary. Is it not? Professor Roy Chaudhary has informed me that he has taught you that in the class. Ankita, was it taught in the class?
I don't know, sir. I didn't attend a couple of classes.
So who has attended the classes?
Yes, sir. Actually, sir, it was taught for normal distribution.
So you know how to use the R, is it not? How to download and use the R. So
yeah,
you can use
the basic.
Yeah. So you can use a R code. Like for binomial, you have binom, is it not? You use the code binom to generate in the R. So similarly, you can use the code which I am typing in the chat window. You can use the code rpois n lambda. Rpois n lambda. So if you are actually going to generate n number of random variables, and from the data sheet, how many random numbers you have to generate? 50, is it not? Is it not? Are you able to hear me? Yeah, so you have to generate 50 random numbers. So for group 7, the lambda is how much? 12. So if you look to the chat window, you can type it like this for group 7. For group 7, it will be RPO is 50 and 12. Can you see on the screen? Can you see on the screen? I mean, in the chat window, sorry, in the chat window? Yes. Not on the screen, chat window. So if you open the R, you can actually download R software very simply. It's a free ware. You can just download it and you can just use it. Just type in the control command window below. I mean, in the top, RPO is n lambda. So n remains constant for everybody because every group has to generate 50 random numbers. But the lambda will change according to the groups. So group 7 is 12. Then it is for group 8, it is actually 25, 27, 17, 28, and for group 12 it is 23. So you can generate Poisson's random number using the R software. So that Poisson's random numbers, or the random numbers that is having a Poisson distribution, will form the number of non-conformities. That means number of defects. All right. So non-conformities is the defects actually. So you will type the defects here. 1, 2, 3, etc. till m. You will type the defects. All right. So once you type the defects, the average number of non-conformities is actually the average of all the C's. So sigma Ci by m. M is actually 50. Now once you get C bar, which is the average of the non-conformities, that is number of defects, you can use the upper control limit, lower control limit, and control limits to plot the C chart. So upper control limit is given by C bar plus 3 into root C bar. Lower control limit is given by C bar minus 3 into root C bar. So if you get a value minus sign for LCLC, then you have to take it 0. But if you're getting some value above 0, then the maximum value has to be taken. Okay, and the central limit, central control limit, CL, it is nothing but C bar itself. Now you can plot the control chart. Now you can see whether any points are out of control using some kind of rules and other things you have already done. And if you find that some points are out of control or some pattern is there, you can remove those points, recalculate the control limits, and plot the revised control chart using the same formula. Only the difference is that when you take the average of the number of defects or number of non-conformities, you have to see how many of the points you have removed. So you have removed 4 points means then now the average will be divided by 46 instead of 50. If you have removed say 10 points, now the average will be sigma c by 40 because 10 points you have removed. So you revise the control limits and replot the control chart. So that is the second task. Now you will plot the OC curve. In order to plot the OC curve, you have to use UCL and LCL values of the revised control chart. That means you are actually finding out beta, which symbolizes type 2 error. So you are given the value C. So you see the equation beta equal to probability that X less than or equal to upper control limit. X means that data point that you are plotting is less than or equal to upper control limit given the C minus probability that X will be less than or equal to the lower control limit given C. And this follows a Poisson distribution. So either you can use a Poisson distribution table, cumulative Poisson distribution table, or you can use a say what the Excel sheet to calculate it. So it is pretty straightforward. You are given C 1, 5, 10, 15, 25, 30, 35, 40, 45, 50. So you have to find out P X less than or equal to UCLC bar C given C. So now I don't know what is UCLC. So for the time being, let us consider this upper control limit to be 6. So I'm just typing here the upper control limit arbitrarily. Let's just take it as 6. So for upper control limit 6 and C value, for example, if you are getting an upper control limit, for example, 6.31 and the lower control limit you are getting say 2.32. Can you see I am typing on the screen? Can you see I am typing on the screen? Yes. So if you are getting an upper control limit 6.31, for plotting the this OC curve, you can approximate it to the lowest positive integer. Approximate the lowest possible integer. What is that? Upper control limit is 6.31. So which is the next integer, lowest integer? 6. You can take UCL as 6. In case of LCL, you can take the next highest integer. So what is the next highest integer? How much? Yeah. So it is 3. So you will take it as 6 and 3. Now let us find it out. So first I will show how this Poisson, cumulative Poisson, that table can be used. So let me share that table also. Can you see the screen? This you can easily find out even behind the back of the Amitabha Mitra textbook in appendix A2 corresponds to cumulative Poisson distribution, or you can easily download these tables from the Google net. Okay, so let us take the case of the first one. So UCL is 6 and LCL is 3. So for UCL 6 and C value 1, you have to find out the probability value. So UCL 6 and C value 1. So what do you mean by UCL 6? UCL means it is actually nothing but it is X in the chart. You're getting my point, X along the column. So X value is 6 because it is X less than or equal to UCL. So X value is 6. And what is the C value? C value is 1. So 1 is actually lambda along the row. So lambda is 1 and 6. 0, 1, 2, 3, 4, 5, 6. So the value is 0.9999. Am I right? Are you getting the point? So just typing it 0.9999. You can round it off to 0.1. I mean 1. Instead of 0.999, you can make it 1. And 3 decimal points will do. So in the next case, X less than or equal to 3 given 1. Can you find it out from the chart? Can you tell me what is the value? What is it? 0.9810, because that one doesn't change, it is lambda. And X value is actually now 3 LCL. So it's 0.9810. So it is 0.9810. So you can subtract these two and get the value for the beta. What is the value for beta? 0.9999 minus 0.9810. So this is actually the value becomes 0.0189. 189. So you can take it as 0.019. Are you getting my point? Is it clear? Is it clear? Using the table?
Yes, sir.
So for the next one, C5, for the second column, that is UCL, P x less than or equal to UCL, can you find the value from the table C5 and the UCL value is 6? Okay, 0.7622. I am typing it here. 0.7622. What can be for the next column? LCL. Just tell me. What is it? 0.2650. 0.2650. I'm just typing. So what is the difference? You have to subtract the first column minus the second one. So it is 0.7622 minus 0.2650. How much it is? How much it is? 0.4972. So you likewise you can calculate. But at the same time, let us see how we can calculate using Excel chart. I mean Excel sheet. All right. So I'm asking once again, is Rupesh Garg present? Okay, so I'm closing the attendance. So we will find out the cumulative Poisson distribution using the Excel sheet. Can you see the Excel sheet, please? Yes. So let us calculate one by one. Let us calculate for UCL 6 and C1. So you can use an equation Poisson.ist. Poisson.dst, that is Poisson distribution. Now x comma mean comma cumulative. What is x here? What is x here? What is x here? You are not audible. Please be loud. How much? Not audible.
6.
6. Okay. And what is the mean? Lambda and C are both the same. What is the mean? 1. Comma, it should be true because it is a cumulative distribution function. Close the bracket. Enter. What is the value you are getting? 0.9999. You are getting the same here. Similarly for LCL, what you are getting, let us see. Poisson.dist. What is x here? For LCL, x value. How much? 3. Is it not? Lambda or C. Mean is same as lambda or C, which is 1. Comma true. What is the value? 0.9810. 0.9810. Are you getting the same? You're getting none. Is it not? Yes. Now let us see for the next one. When C equal to 5. So when C equal to 5, again Poisson. So C equal to 5. X is the same, 6. Mean is 5. And it is true. Enter. 0.7622 or 0.7621. Yeah, 0.7622 exactly. 0.7622. Are you seeing that on the screen?
Yes.
Yes. So now let us go for LCL value, which is 3 and 5. Which is 3 and 5. So 3 is the X, 5 is the mean. And it is truly a cumulative distribution function we are trying to find out. 0.2650. You're getting the answer, is it not? Okay, now where the Excel will really help you is that see the values for C. See, if you go to the table, you can see the C value, that is lambda. Lambda value starts from 0.1 and up to 15. You have a maximum lambda value only up to 15. Whereas in the question, you are asked to find out up to 50. So for 50, what will be the answer? Let us just see. When C equal to 50, Poisson DST, the X value remains 6, C value is 50, and true, enter. See 4.74 10 raised to minus 15. See, the value has gone like that. So similarly, you have to find out for the lower limit also. So if it is 0.00000 like that, you can take it as 0. All right, no problem. You can take it as 0. If it is too much zeros, what should be LCL also? Let us see. LCL is 3, 50, true. Minus 18. So it is long zeros actually, 0 like that. So it is 0. So you can type here 0. So you can plot the curve like that. Is it clear? Now, how to plot it? Is it clear? Yes. So this is how you have to do it. So your things are also available here. And if you have some doubt, you can easily find out NTPL lectures also available in the net. Or you can read the Amitabha Mitra also. This is very similar to that you have done in the previous class for PE chart. So there is an MPTL lecture of Professor J. Takhar, who was our former faculty in our department. So he is also explaining this thing exclusively how to calculate OC curve for P chart, C chart and all. So if you type that video lecture, NPTL lecture for OC curve for C chart, then Professor Thakkar's NPTL video will come up. You can also see that, but it's not required because this is more than sufficient. So you can now plot, and what will be the plot? What will be the x-axis for plotting? What will be the x-axis for OC curve? I mean, what is the x-axis or and y-axis? Can anybody tell me what is the y-axis and x-axis? X is C, Y is beta, and X is C. Very good. So you will have beta values on the y-axis and C values on the x-axis. So likewise, you can plot. Similarly, you can go to the report template. Nothing different. The same way, plot the write the random numbers with Poisson distribution. Plot the trial control charts. If there are some out of control points as you feel, you write the inference and you can remove, otherwise it is fine. Recalculate the control limits and plot the revised control chart. That recalculated UCL and LCL will be used to calculate beta values. You can use the Excel sheet for that and plot the OC curve, and some questions are there. So is it clear? Yes. Now you can start doing. There are several number of control charts. Okay. If you go to that U chart, it becomes a bit more complicated as such. Because U chart, the control limits are revised many times. So if you go to the internet and see, you can see the control limits are actually a bit fluctuating. Then there is something called Kusum chart, which is known as cumulative sum chart with V masking. That is also very much utilized. I myself have utilized this Kusum chart. Give me a minute. Maybe I will able to show you something. Yeah. So can you see the screen? Can you see the screen? Yes. So this was a paper that was written long back by me when I was in States. Now I will send this paper with a lot of corrections, but I have plotted this chart. See, plot of cumulative sum for estimated ECM model, error correction model. Okay, so this is a cumulative sum chart and it is plotted in mini tab. So this is a bit more higher version. So there are different ways of plotting cumulative sum chart. Cumulative sum, the short form is CUSUM. Okay, so similarly, I will also show you one more chart that was actually plotted and published. 1 minute. Most probably I can show you here. Yes, you can see it here. Can you see the screen? This is an article by a very famous, world famous energy scientist from India, Sajal Ghosh. So it was in elsewhere in energy policy. So he have used these charts. See, the application of the charts not only in quality control, but it's in applied statistics, econometrics, plot of cumulative sum of recursive residuals, plot of cumulative sum of squares of recursive residuals. Recursive residuals means you go for recursive least squares, an estimation method where you go on adding beta values. For example, the first one will be y equal to alpha plus beta 1 x1. The second equation will be y equal to alpha plus beta 1 x1 plus beta 2 x2. Now the third one will be y equal to alpha plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Likewise, you conduct your regression for all the variables in steps by adding the coefficients beta 1, then beta 1 and beta 2, then beta 1, beta 2, beta 3, likewise. So every time you add a coefficient beta, it is known as recursive, and every time you get residual. So in order to understand certain properties of such residuals, Ghosh sir has plotted this cumulative sum chart. And you can see the V masking kind of thing, what he has done. So these are all very much utilized. So is it clear up to this? Yes. So you can start doing. And I have created the folders in the Microsoft Teams under the main folder QDC LAB 5. So I have created the different folders for group 1, 2, 3, 4 up to 6. So you can upload the assignment, lab assignment in the specific folder for your group. And data sheet and report template are available there. So you have noted down now how to generate the cumulative Poisson distribution. You have noted down. 1 minute to type in the chat window. Want me to type in the chat window?
Yes, sir, we've noted.
Yeah, I'm just typing it once again. Once you start typing in the Excel itself, it will pop up actually. But I'm just typing it poisson.dist. Can you see in the chat window? Poisson.dist. X, true. X is nothing but that value you are dealing, X, UCL or LCL value. If the UCL value is in decimal, the lowest possible integer. And when the LCL value is an integer, the next highest possible integer. So the X will be either UCL or LCL. C will remain the same. That is already given. True means that you are trying to find out cumulative probability distribution. You will get this answer. So thank you very much. You can start doing now. See, those who are absent, kindly ask them also to be involved in this exercise. All right, in today's class. So thank you. You can start doing, you can leave and start doing the exercise.
Thank you, sir.
Thank you very much. Yeah, Yeshwan, thank you. Thank you, Satyam. Ishita.